I don't mind you coming
here. Good morning, good afternoon, good evening, whatever the case may be. We are back in better than ever, and today we were talking about problem solving using Pythagoras' theorem. Part 2, we did a little bit of this the other day. Let's get to it, shall we? We'll get back to the cars and the classic. Just what I needed towards the end. Okay, I got 2 examples lined up for you. As always, the most important part of solving some of these is a nice diagram. Town A is 50 kilometers south of Town B. So let's just get our directional dealio. Some might call it, I don't know, a compass. North, south, east, west, just for reference. And of course, this is going to be perpendicular. So Town A is south of Town B. So we got 2 points here. We've got B and we've got A. And we know that it's due south. So that's 50. And Town C is 120 miles east of Town B. So that's, I don't know, maybe here we call this. And boom. So this is 120 kilometers. Is it quicker to drive directly from A to C by car at 90 kilometers per hour or from A to C via B in a train traveling at 120 kilometers per hour? So let's see this, okay. What are we doing? Is it quicker to travel from A to C or from A to C via B? Okay, so the first thing is by car. At any rate, we have to find this distance, which I will call D. We have to find how far that is. So since the directions are perpendicular, north-south is perpendicular to east-west, we are going to use Pythagoras. So we can say that D squared is equal to 50 squared plus 120 squared. So D is going to equal the square root of that. And just so you know, and I'll show you real quick on the calculator, you don't have to figure out what 50 squared and 120 squared is. I put degrees there, I don't know why. You can just crank it in your calculator. So 50 squared plus 120 squared. We can use our square root button, which is right here, control square root. 50 squared plus 120 squared is 130. So we know that that value is 130. I'll go ahead and put that in your notes for you. So that should be easy to work with. Okay, so 130. And so we have D is equal to 130. Okay, and that's going to be kilometers. Okay, so let's go back. From A to C by car. A to C by car at 90 kilometers per hour. Well, the time, distance equals rate times time. So if and I need to know how long it is, so if I divide by R, time equals distance over rate. So we're going to have to take 130 and divide it by 90. And let's see what that is. 130 divided by 90. Bam. And we get 1.4 repeat hours. Okay, so that'll take 1.4 hours. 1.4 repeat hours to be exact. Or from A to C via B, meaning we would start here, go to B. I guess I'll do it in blue. Start at A, go to, oops, I'll do it in blue. Start at A, go to B, and then go to C via train. So via train, via B I should put, at there, 120 kilometers per hour. Well, first we have to figure out how far that is. The distance is 170 because I go 50 kilometers plus 120. So that's a total of 170 kilometers. And then I have to take that and divide it by the speed of 120, and let's see what that is equal to. Handy dandy calculator, 170 divided by 120, and that is equal to 1.42 hours, which is less than 1.4 repeat hours. So that's 1.42 hours rounded to 3 significant figures. So the answer is A to C via B would be faster. Okay, so hopefully that wasn't too horrible. Just one more. An equilateral triangle has sides of length 12 centimeters. Find the length of one of its altitudes. I'm going to cheat and use my triangle drawer here. Okay, equilateral triangle. That seems to be about equilateral right there. Okay, oops. Yeah, let's see if I can grab it and move it a little bit. No, all right, we'll leave it there. So we know that we have 12, 12, and 12. Find the length of one of its altitudes. Well, all of its altitudes are going to be the same, and recall that an altitude is a line drawn from any vertex to perpendicular to the opposite side. So I'm going to choose from here to here. It could have been from here to here or from here to here. They're all the same length. So I'm looking for that length, x. Altitude by definition is perpendicular to the opposite side. And also the altitude of any equilateral triangle bisects the opposite side. In other words, from here to here is the same as from here to here, which makes this length from here to here 6. So I have a nice right triangle, and I'm looking for the length of the altitude, which I called x. So this is a simple Pythagorean theorem. X squared plus 6 squared equals 12 squared. X squared plus 36 equals 144. X squared, if I subtract 36 from both sides, is equal to 144 minus 36 is going to be 10. Oh my goodness. I'm having a little bit of a brain cramp this morning. So 3, so I thought it was 8. 3 minus 3 is 108, so that's 108. So I take the square root of both sides, and x is equal to square root of 108, which is a perfectly acceptable answer. Of course, we could do the square root here and see what it turns out to be, and that is going to be about 10.4. Square root of 108 is a better answer, so we're going to say about 104 centimeters. All right. That is all I have, ladies and gentlemen. I hope you enjoyed it. I know I did. And let's just get back to and finish up with Just What I Needed by the Cars. And with that, I am...